Hi, everyone, and welcome to another episode of Pathfinder presented by Payload, the leading digital media company in the space industry. My guest today is Dr. Casey Handmer, the founder of Terraform Industries, a company that's developing a carbon-neutral supply chain for cheap, unlimited natural gas. But that's actually not why he's on the show today. Casey has written some of the most insightful pieces about the space industry that I've ever read. He was one of the early supporters of Starship and the impact it would have on the world, and he's written a lot about it. An engineer and scientist who previously worked at Hyperloop and JPL, I'm thrilled to have him on the show today. We have a lot to get through, but first, a quick word from our sponsors. This week's episode is brought to you by Epsilon3, software for complex engineering, testing, and operational procedures. Epsilon3's web-based procedure platform enables technicians, operators, engineers, and management to instantly access information around current status of operations, release history, and historical reference of procedural content. Epsilon3's platform is better suited for coordinating space development workflows than word processing software, Microsoft Excel spreadsheets, and other applications that are not tailored for the industry. For more information, check out epsilon3.io. Casey, welcome to the show.
Thank you. It's good to be here.
So you're a lot of things. You're a PhD in theoretical astrophysics, a pilot, a musician, an entrepreneur, an avid and very serious world traveler, and importantly, you're a big proponent for a better future for humanity. Interestingly, though, and I did my homework, Casey, you started as a debate coach. So tell us how you went from that to building a company now that's attempting to move the world beyond fossil fuels.
Well, that was a very long time ago, but I did high school debating, and I think it's a great thing. Everyone should do it. And so when I left school, I was happy to come back and help out and give back a little bit. And I retained some ties to my alma mater, high school and undergrad and grad school. So when someone asks me for a favor, if I can, I help out. I think it's part of paying forward the opportunities that are given to you. And I guess that now I'm kind of approaching that at larger scale, but yeah.
So I assume you're not doing any public speaking coaching anymore.
No. I mean, I haven't been asked, to be honest. But I do have a few blog posts if you want to dig through the archives talking about the essence of good speeches for certain applications. But I mean, the nuts and bolts of how to speak publicly are been written about at length for many thousands of years. I don't know if I can really contribute much to that conversation.
There you go. Well, tell us a little bit about your career arc. You're building a very interesting company right now called Terraform Industries. Maybe talk a little bit about how you got there and what it is you're building.
Yeah, I mean, the story of how I particularly got here is kind of contingent and path dependent, and maybe less interesting than the general question of can anyone get here? And I think actually, entrepreneurship is sometimes seen as this kind of big scary thing, and it is certainly scary at times, but it is certainly something that I think more people could do. And I'm not saying that you necessarily should do it, but you shouldn't. If you need to be talked into it, as they say, maybe you shouldn't do it. But it's certainly something I never saw as particularly naturally a part of my life plan. I never saw myself as needing to call myself the founder or something like that. But eventually, I just came to realize that there was an aspect of the future, of my vision for the future, that was not on track to occur. It was not going to happen, but it needed to happen, and no one else was going to make it happen. And so, at that point, my choice is, change my mind and decide it's not necessary, or plunge in and roll up my sleeves and take a crack at it. Obviously, with an intention to not waste my time, which is where I find myself now. And in this case, it's just very particularly something to do with energy that actually kind of sprang from some creative work I was doing in terms of imagining how a Mars city might work, maybe in the 2030s, sometime, kind of Elon Musk's and other people's vision for self-sustaining Martian civilization, and then realizing that actually a lot of the technology you'd have to build there would also be super applicable here on Earth, and in some of it in particular would be transformational when it comes to energy availability and prosperity and the kind of destruction of poverty and kind of very deliberately moving ourselves into a better future and also addressing climate change.
So Terraform, as I understand it, the business at its core takes sunlight and air, if I'm being very simplistic about it, to produce cheap natural gas. Now, we could have multiple episodes dedicated to just your business and the technology, but that's for next time. But
I'm looking forward to the quiet episode someday. Yeah.
Yeah, there you go. Well, tell us a little bit about where the company is today and where you expect to, what is your kind of maybe near-term product roadmap?
Yeah, so actually this morning, the kind of second in command on the technical side and I were going through the onboarding documents because we've just hired 2 new great engineers and wanted to revamp that. And I was like, holy crap, we've got 11 people in the technical team now. So that's a lot. I feel like that's a lot further on. We're about 2 years in now, just over 2 years in. I think I incorporated the day after the first Dune film came out. So, there's a milestone.
And Dune 2 is about to come out in March.
Yeah, first of March. It's been delayed, but I can't wait. Just kind of, you kind of get started in it. And it turns out that it's what you're trying to do is much harder than you thought. But also, really good people come along and help you out, and you end up getting much further along than you would have thought you could have, knowing now how hard it is, if that makes any sense. So it's been great. And right now we're working towards the end-to-end demo. So I don't know when this is coming out, but maybe by the time it does, we'll have something to announce on that front in terms of success. But right now we've kind of developed these 3 core technologies independently, so we can, essentially maximize the rate of progress. And very soon we'll be plugging them all together and actually converting electricity into synthetic natural gas using our process, which is it's kind of unique in its way for the first time ever, and then handing that gas off to a customer and converting that into money, which I think is the key step, right? It's like showing that you can use technology to make more value, and then obviously from there it's ramp up, increase production. But like once we make it for the first time, we can put a dot on the graph with number of megawatt hours per year converted into natural gas or whatever, and ultimately that's going to be a very, very large number.
Well, it's very exciting, and I do have one last question on the topic, which is that you've written once that you believe that humanity will move beyond fossil fuels as soon as 2040. Do you still believe that?
I think when we started out 2 years ago, maybe 3 years ago, in terms of my early ideation with regards to this business plan, it was kind of the middle of COVID, and there were some bumps and lumps in the supply chain for solar and so on. But the last 2 years in particular on solar and batteries have come in unbelievably strong. Just for reference, the year before last year, so 2022, globally we deployed about 250 gigawatts of solar, and last year was about 450 gigawatts. So it's almost double. And that's, so cumulatively, we're now over a terawatt of solar worldwide. We're producing more power from solar than we are from nuclear. The deployment rate of nuclear has never been anywhere near as high as the solar deployment rate is right now. So yes, there's some finesses there in terms of capacity factor and so on, but it's pretty clear where the trajectory is heading. And I think it's much more widely accepted now that solar plus batteries can effectively substitute for any other form of energy at lower cost in the electrical grid, almost anywhere on Earth. There's a handful of exceptions we can delve into if you're curious, but for 98% of the world's population, that's the story. And I think the next major step in terms of breaching the kind of general zeitgeist is that what you can do for the grid, you can also do for hydrocarbon supply chain, and it'll be so quick. Like compared to just how achingly slow it has been to displace, say, automobiles with electric cars, which are great, by the way. Like they're very competitive, but even then, it just takes a very long time to roll over the existing fleet, let alone buildings. On the supply side, it's not unusual for a fracking well or something to only last a few years anyway. So like just the production turnover, if you like, is much, much higher. So I think we'll move very, very quickly. And yeah, if you just kind of slide the curve forward, then the volumes and costs get to the point where we would have done something horribly wrong to not be essentially done globally by the early 2040s. In my wildest dreams, I think we might get there by like 2037. That would be definitely a lot of gray hairs, but like earning a lot of gray hairs getting that done. But it would be definitely worthwhile. If we the faster we go, the better. Frankly, every marginal gigawatt of conventional production that we displace saves 100 lives per year. So, and that's just from the effects of pollution. That's not counting climate change. So, very, very keen to get that done.
Well, Casey, I'm smiling because I have so many questions, but we're not going to get into a rabbit hole. I promised myself even before I was like, we're not getting into a rabbit hole in this converation. So, and we are a space podcast, so I'm gonna try to reel it back into the space side.
Yeah.
And I want to highlight. Space is where it's at, but I would love to have a conversation with you about your company and your views on where we think energy production is going to go over in a decade or two. So that's going to be for next time for sure. But I do want to highlight that you have a blog that I love. It's very easy to find for those listening. It's if you just Google Casey Handmer's blog, it's the first thing that pops up, and we'll put it in the show notes.
That's what it's called, yeah.
But there it is, yeah. But it is something. Actually, I don't say this a lot. It is one of my favorite things to read regularly. And one of the topics that you've written about extensively is Starship. And you've been very insightful about Starship really ever since 2019 when you first started writing about it. And there's one article you read, and we're gonna jump around across a few different topics that you've written about. But one article that you wrote in October 2021 that I've read and I've reread easily a dozen times is called "Starship is Still Not Understood." So I want to jump right into that. Do you believe? Now, you wrote that piece first in October of 2021. It's now February of 2024. Do you still believe that Starship and its expected impact is still misunderstood today?
I'd say it's better understood than it was in 2019. And in particular, I'd say that the entrepreneurial half of the space industry has definitely picked up on it. DoD has picked up on it. The launch industry has picked up on it, as you would expect. But in terms of the legacy business models that service that space, I think that I've not yet seen any evidence that they kind of really got their head around what this will do for them.
Do you think that Starship is still a controversial topic within NASA?
Yes. I would have said no a few months ago, but the Smarter Everyday guy, Destin, gave a talk about the Artemis program. I think he gave the talk a couple of months ago, actually, but it was recently published. And it was a talk to some NASA people at Johnson Space Center, which is the center of the human spaceflight program. And just I don't agree with everything that Destin said, obviously, but just the tone of his conversation and the questions that he got and the discussion from the audience and so on, it seems quite clear to me that the vast majority of people who are kind of involved in the nuts and bolts of that program, maybe not, if you sat them down and talked to them about it, they would agree with you. But in terms of the integrated product of their work over the course of the last few years has been continuing down the path that, as an organization, their management and so on don't really fully grasp the implications here, which is kind of a bit of a worry, if you ask me. I mean, it's not exactly a foregone conclusion that Starship will work, although I think it's quite likely at this point they will get to orbit, and certainly on a long enough time scale, there's no fundamental physical reason why it couldn't work. But on an economic basis, maybe it's not guaranteed that they'll hit $50 a kilogram to orbit or something like that. But there's some probability that they will, right? And so you should devote some resources to dealing with the outcome that would occur if that did occur, just to make sure you've hedged your bets. Because if they do achieve that, it's not lights out for NASA by any means, but it will cause serious problems for a variety of the existing business models there, which means okay, the CEO has a bad quarter or whatever, but actually what it means is tens of thousands of people's lives and livelihoods, their jobs are on the line. Hopefully they wouldn't be injured or killed, but certainly their livelihoods are on the line. And now is the time to be thinking about how we deal with this, because it takes an awful long time to turn that ship.
Right. Well, what you're alluding to is a fair point. And I guess you could also say a lot of that could be prevented if NASA changes the way it is building and, the way it thinks about architecture and mission design, both for science and human exploration. I would assume you'd agree with that. But there's still time to change that.
The best time to start was 4 years ago, and the second best time is today, right?
Right.
It's still not too late, right? But the problem, I've been, at the end of the day, I don't sit in these meeting rooms day after day after day, right? I can only look at what's occurring on the outside and make inferences based on what we see in terms of behavior. But it does seem to me that on an organizational level, that's not to say any individual is responsible, but as an organization, there's kind of stuff that occurs within the Overton window and then stuff that's outside it. And it may be the case that window is a little too narrow, and that the people involved, although they may individually feel frustrated or aware of these issues or worried by them, are not really able to build the consensus they need within that organization to actually address these problems head on in a productive way. And that's a major problem, but we see this across the board. We're kind of in the process of seeing this occur in slow motion in Boeing right now, maybe for the last, depending on who you ask, the last 20 years, but it certainly has become more obvious in the last 5 or 10 years. It's pretty obvious that if they continue on their current path, they're going to be in serious trouble. And everyone involved in that organization, plus their regulators and so on, hope for a positive outcome, but hope is not a strategy. And so some kind of, the longer we wait, the more catastrophic the intervention will have to be in order to get a fatal outcome. And in particular, I worry about this in the context of JPL, actually, because there's about 10 different NASA centers and they all have their own areas of expertise, and Starship only directly bears on a handful of those. But JPL has spent the last 70 years or something, becoming essentially the world experts on building these exquisite, incredibly reliable, incredibly light, incredibly, I say with love, over-engineered devices to operate on other planets, subject to a series of constraints that are in the process of going out the window, and in many ways already have. And so you have to ask yourself, well, if it turned out that the JPL's business now looks an awful lot like quantity over quality, could they compete in that world? And would their competitive moat relative to other companies that can also build rovers and robots that operate in harsh environments like mining or undersea operations or whatever, would they be able to effectively compete at lower cost on JPL's turf? And the answer to that, I think, is unequivocal yes. I think that I'm directly aware of at least a dozen startups in the LA area who, given half a chance, would be all over the planetary rover market. And then what does JPL do? 7,000 experts with salaries and mouths to feed, and they kind of hope that they get a directed mission to fly a big Cassini-like orbiter to the outer planets, and maybe Mars sample return gets underway again. But that's not nothing. But like by rights, JPL should be front and center, right? Like they're the experts. There should be JPL and NASA branding all over everything that SpaceX is doing all over the moon and Mars. And right now, if I was SpaceX, I would not be putting them on the critical path. I'd put it that way.
So let's take a step back, because you're alluding to a couple of very important things. Let's take a step back and just talk about Starship and what it could potentially do, right? In what ways does Starship challenge traditional constraints and design philosophies in both spacecraft and mission planning?
So I think you could kind of maybe divide the history of rockets into a few different sections, and the first section would be like fireworks and weapons of ore, perhaps in the gunpowder-fed rockets in the medieval period or something like that. They're featured in the American national anthem, for example. And then you'd have like the development of liquid fuel rockets prior to, during the Second World War, and immediately thereafter, in which trillions of dollars are invested by the United States and its allies and the Soviet Union as systems to deliver ICBMs. And then you would have the growth of commercial space and human space flight, which kind of has a different set of requirements, a different kind of customer profile. And as a result, the rocket systems that end up kind of developed for that market are quite a bit different in their own way. Although I wouldn't necessarily say the space shuttle was anywhere near an optimum for any market, but it is what we got. And now we're kind of entering an era where I think Elon Musk recognized 20 years ago that a lot of the stuff that previously was pretty much unobtainium when it came to building rockets, particularly in guidance, navigation, and control, could be done with much more commercial off-the-shelf hardware that didn't really exist before. And now, with their goal of building cities on Mars and on the moon, it's super important that they figure out how to solve the mass problem. And so whereas the previous generation of rockets was all about, how do we get this particular satellite into orbit with a particular reliability, the next generation Starship is all about, how do I transport cargo from Earth to low Earth orbit and from low Earth orbit to various destinations in the solar system in at least 100-ton increments as cheaply as possible. No questions asked. It's kind of like the Uber of moving stuff around in space. Like, how do you get the transport thing below the API? And that's different, right? It's very, very different to what we saw in the past. It's got much more in common with, a bus route type model or regular shipping, container shipping type model than, bespoke courier. And I think that it changes a lot, and as Paul Wister likes to say, you can get away with an awful lot of sins in terms of your architecture if you loosen the mass constraint. Like, mass solves an awful lot of problems. And that's definitely true, right? And it's important to realize, like, especially in the context of building a base on the moon, say under like the default Artemis program, you end up with some like miserable, tiny, smelly can, like is featured in the first season of For All Mankind, which you can just barely service with a handful of astronauts at a time. But like, what's the point? Like, it's about as useful as the midget submarine and about as safe. Whereas if you say, well, it's going to cost us $10 billion of development, but at the end of that, we'll have this fully reusable launch platform where we can, if we so desire, drop 1,000 tons of stuff a year, no questions asked. Now you're talking, right? Now you can you essentially solve the problem the same way the United States solved its logistical problems in the Second World War, which was to bury the Axis powers under just insane piles of material. Yeah, I mean, there's no other way of solving it. Like, if you want to build a city on Mars, you have to move 1 million tons of stuff there. So you have to figure out how to solve that problem.
Even if the industry fully understood, like the industry at large fully understood the implications, do you think they could adapt to the launch capacity that's coming? Do you think we even have the ability to adapt quickly to what's going on? Even if everyone said, "Hey, we're this is happening. This is a paradigm shift, and we all need to take this very seriously.
Well, so I think that question you might be trying to ask, does Starship have a customer? Like when Starship's up and running, will there be enough demand for it? And I think that the answer to that question is, well, if it turned on tomorrow, the answer would be no from the outside world. But SpaceX foresaw that a long time ago, and they became their own customer. And essentially, like the marginal value per Starlink satellite that SpaceX is able to launch is pretty much constant. Like there's not much, like they're basically nowhere near saturating demand, I'll put it that way. So every additional satellite they launch just makes them more money. And that will continue for the foreseeable future. And so they'll always have a very robust source of internal demand for that launcher. And then they can fit other stuff on the side. As far as industry in general, yeah, sure. It will adapt over time as these things always do, particularly if other launch providers compete and force prices down far enough, which I think is probably a matter of time, although maybe longer than most people would think, given the relative lack of success of the companies that have sprung up to compete with SpaceX thus far. But then if you think about like the specifics of existing organizations on their own terms, I'm not convinced. I think a good number of them are in for a nasty shock. And we'll end up seeing, I mean, we've seen this in the past, right? We've seen major kind of boom and bust cycles in the aerospace industry over the last 50, 60, 70 years. And for much the same reason. So for example, when Boeing introduced the 4-engine 707, when everyone else was still flying piston propeller planes around, like some of them tried to compete, but they were really not long for this world. And now Boeing's getting a taste of its own medicine kind of on that front. And I think it would be a fabulous thing if JPL was like, okay, well, in order to exploit Starship, we need to make sure that every single launch window we've got 500 tons of stuff ready to go to shoot it off to Mars. And in the meantime, we'll be launching the world's largest space telescopes, and we'll be launching fleets of uncountable numbers of moon rovers and stuff like that. And they wouldn't even have to build them all in-house, right? They could do the engineering and prototyping and then do contract manufacturing. But JPL currently is not set up to support mass production or even like support the design and development of products in mass production quite deliberately. But it's hard to see like an alignment between the planetary exploration goals and this mass capacity and JPL's role in that unless they square that circle.
So you quote a number of times 10 million per launch as a sort of long-term cost on Starship. I'm curious if you think that's feasible by the end of this decade, and what helps SpaceX get that number down to 10 million?
Yes, I think it's feasible. In order to do that, they would have to achieve reuse not just of the booster, which they've currently pretty much mastered with the Falcon 9, but also the second stage, the Starship component. That's not a foregone conclusion. That's going to involve some learning, right? It might take a while to get there. I think if they had carte blanche as far as launch whenever you want, they would get there a bit faster. It certainly seems to me like right now that the major break on their progress is that every single time they launch, they have to go through this regulatory process, which exists for a reason, but at the same time, Elon Musk and Starship are currently solving a problem that otherwise would potentially completely destroy the United States with regards to strategic access or competitive access to space. And sometimes I wonder, look, would Elon tone it down a bit on Twitter attacking the Biden administration if his agencies, which he oversees, were, told to speed things up a bit or to get out of the way? Because the problem is, if he's busy on rockets, he's not shooting himself in the foot on social media. But if he's just sitting there waiting for a launch license for 2 months, things go sideways. I feel like we could have a grand bargain on that front, and it would be, for the betterment of all. But no, in terms of the fundamentals, you can fill and launch a Starship for a few $1 million in fuel, and right now we have aircraft where essentially we can fly them where fuel is some fraction of a relatively large fraction of the overall operating cost. And the Starship wouldn't necessarily achieve as many cycles as a 787 or whatever would over its lifetime for the amortization. But at the same time, the Starship is actually, relative to its size and the revenue per launch that you would earn, and the lack of competition, is significantly simpler than an airplane. In most important ways, there's less material in it relative to an airplane. There's less regulatory burden, at least until they start flying humans around that aren't astronauts. And so, I think you could definitely get down to 10 million long term, maybe even less. But But that's the rough order of magnitude. Certainly much, much less than 100 million, and probably much less than 30 million. And I'd say less than 30 million in the near to intermediate future.
All right. Well, Casey, we're going to take a quick break. No pressure. We're going to take a quick break. We'll be right back. We're going to talk a little bit about the moon and Mars and Starship, but stay with us. And great prediction on the 10 million. We're gonna write that one down and see how you do. But stay with us. We'll be right back. By utilizing Epsilon3 software platforms, engineers can create builds, track builds through AIT, revise and test procedures, and more. Not only will engineers save time and frustration looking for information in multiple places, but it will speed up your AIT processes. Unlike using simple documents or generic project management tools, Epsilon3 provides synchronization and standardization that streamlines and refines processes and procedures. Check out their website, epsilon3.io, for more information. Hey, Casey, welcome back. So I want to talk a little bit about HLS. Starship has been selected for HLS. And even though it has, why don't you think Artemis has been redesigned yet, right? The Artemis architecture is very similar to Apollo in cargo capacity to the surface, but it's pricier and it's slower. So tell us a little bit about why you think Artemis has not been redesigned yet.
Well, it's a complicated question. First, of course, NASA is legally required to build SLS and Orion and to use them for Artemis. Right? That is, Congress holds the purse strings and Congress told them so. Now, you can construct an argument that perhaps the NASA administrator should have pushed back and said, look, what you're asking me to do is counterproductive. Would you be so kind as to reconsider? But it's unlikely to occur because Congress did it for a reason. And then at the same time, I would say that, east of the Rockies, much of NASA would probably be pretty skeptical of either Blue Origin or SpaceX's ability to deliver HLS in a meaningful timeframe relative to their schedule. And so, we hear Mike Griffin and others, recently complaining. Doug Lavera had a go at this a few years ago that NASA should do a big NASA-centric lunar lander like they did last time and give the specification and design to one of the OG contractors and do it the right way. Meanwhile, the reason Starship won HLS contract was because they're building Starship anyway, and so they can offer a pretty good price. And I think it's kind of nice, NASA currently gets to hedge their bets a little bit as regards both Congress and its various requirements and constraints, and also its constituencies, NASA's constituencies across the country, and also keep Elon Musk and SpaceX on a tight leash. But I do think that if I had to bet my own money, I would say that if the Artemis program actually results in landing humans on the moon multiple times, that Starship will be doing essentially all of the duty, and you could delete SLS and it would not make much of a difference, other than, of course, saving some money. It's kind of a shame. I mean, I wrote about this more broadly in the context of a different blog on SLS, but it is kind of a shame that so much of NASA is forced to spend so much money building a rocket that is so useless. Imagine what they could achieve if they're actually building towards HLS or a Starship, Artemis program that actually did something. $4 billion a year is a lot of money.
Well, after a lot of kicking and screaming, Blue Origin got their own few billion last year. Blue Moon received its own contract. Where do you put Blue Moon in all of this?
I don't know. I don't have much insight into what Blue Origin is doing. I think I'm happy that there's other organizations that are attempting to be part of the situation. I wish that their approach was less zero-sum. I think it's a bad look in general when they spend all their time complaining about SpaceX getting contracts. Blue Origin still hasn't launched a single rocket to orbit. It's 2024. How much longer do we have to wait? I think there's a very well understood stair treads towards having industry recognized competence in this field, and it begins with launch something to orbit more than once, achieve booster reliability, and then recover your booster and start recovering a second stage and get reusability, and then launch things to the moon, and then put stuff in lunar orbit, and then land something on the moon, and then bring something back from the moon. It's not particularly radical. And if I could fault Blue Origin, I would say they've spent a lot of money and moved extremely slowly. And the reasons why, kind of beyond the scope of this conversation, I don't really have much insight. But I think if we were to understand why, that would be very interesting.
So you've done a number of very interesting analyses and proposals, I should say, for lack of a better word, around different uses of Starship, how it can become, how it can be used as a space station, how it could be used as a moon base. But I want to talk for a second, because you actually also did a really great breakdown of why it's not feasible for the current Artemis program without Starship to scale beyond what we did during Apollo. So effectively, without Starship, all we would be doing is basically repeating Apollo, which was just sending a few astronauts to the surface for, call it 5 to 6 hours at a time, and really not making a big step forward. Maybe talk a little bit about that, why a non-Starship Artemis program doesn't really move the needle.
Yeah, so without Starship, Artemis looks a lot like Apollo 8 in that you could launch the capsule around the moon and then have it come back. But there's no capability to enter low lunar orbit, and there's no capability to land on the moon. Kind of the way Artemis is being construed is a bit ass backwards, because actually landing on the moon is the hard part and getting off the moon is the hard part, and actually building a launcher is something we've known how to do for many, many, many years. And yet we spent 20 years and $100 billion building, a slightly worse version of the Saturn V booster and a much worse version of the command module. Patted ourselves on the back and we're like, okay, well, what next? And so you end up with this like lunar gateway thing, which I think, well, if anyone thinks it's controversial, come at me, but like it's useless. It's just a bunch of additional complexity with no benefit. And that's part that can be provisioned, it can be built without Starship. It doesn't get you any closer to the surface of the moon. It's just like, yeah, another space station, but this one's even further away and even more expensive. Okay, like we're going in the wrong direction here. So we're super lucky. NASA is super lucky that the Starship came along, because without it, they're kind of in dire straits. And actually, if you look at the first round of the HLS competition, there was the national team proposal and then there was the Dynetics proposal. And the problem with both those proposals is they did not pencil out, right? So like you can read the feedback that the box checkers and so on had when they ran the numbers on that. They're like, well, yeah, so this does not currently close on a mass basis, which is basically the same way as saying this would only work if moon's gravity was a lot lower, but we can't change the moon's gravity. So like over the course of the development of that program, you're not going to magically find a bunch of extra mass, right? Things only get heavier, things only get tighter. Meanwhile, the Starship is designed to launch enough people and cargo off Mars back to Earth. So it has 6 or 7 kilometers a second of delta V intrinsically, which is enough to fly from low Earth orbit all the way to the surface of the moon, and then all the way back from the moon back to Earth without refueling along the way. Of course, you could refuel it around the moon if you really wanted to, but you don't have to. And it actually has a lot more in common with some of the very original Apollo architecture ideas, like the direct descent idea, that kind of didn't get off the ground because they couldn't build a rocket that was big enough to do that in a single launch. But with Starship, they're designing it so you can refill it in low Earth orbit, which means effectively you're good to go with another 100 tons of cargo and 7 kilometers a second of delta V in low Earth orbit, which is almost as good as you have on the surface of the Earth. It almost reduces the Earth to low Earth orbit step to a trivial one, which is how it has to be. And this is amazing, right? Like President Biden, to his credit, I think put a moon rock on his shelf in the Oval Office, which is pretty neat. Like not many countries actually have moon rocks, especially not as much as we do here in the United States. But if you launched a Starship, as currently designed, to the moon, it landed, it stuck out a robot arm, loaded up with as many rocks as it can carry and flew it back to the Earth, you would have enough rocks that every single middle school child in America could have a rock the same size as President Biden's. Like,
that's a great stat.
That'd be incredible, wouldn't it? Like, oh, here's your moon rock.
Yeah.
Welcome to grade 5. Here's your complimentary moon rock. It kind of crashed the market slightly. Halve the value of Steve Jurvetson's collection overnight, but I think it'd be worth it. Sorry, Steve. But it's kind of neat, right? And so you say, well, for the same money, I can launch 1,000 times as much stuff to the moon. That's transformational. Now you're talking like, I can do a moon base with 1,000 people in it. It's like one of the Antarctic stations. You can actually get real stuff done, and people can live there year round. And you've got enough cargo capacity that you can have rovers and drilling teams and multiple independent projects and satellite bases, and you can have a gateway orbiter if you really, really want to. But I just don't see the point.
Starship is a necessity for Artemis. I think we've established that. Let's talk about Mars.
Yeah.
So, given the way NASA has approached Artemis, we will be back on the moon in one way or the other. By the end of this decade, at least that's my belief. And after that, the goal will be Mars. How involved do you think NASA will be in a Mars mission, a Starship Mars mission?
Well, that's a question for NASA at this point. I think the scale of the Mars problem is big enough that every organization that wants to be involved could get involved productively if they're prepared to invest the money necessary to contribute some hardware. And the canonical example I reach to is Caterpillar, right? Caterpillar spends billions of dollars every year on R&D, so they could peel off a small fraction of that and devote it to building Caterpillar branded moon rovers or whatever, and it would more than pay for itself in terms of the halo effect on their brand and in terms of their ability to recruit and retain really, really top engineers who are innovative, right? And there's no law of nature that says that SpaceX can't do that. And if Caterpillar doesn't do that, SpaceX will have to do it, and then Caterpillar will have another competitor. As I think, I can't remember the name of the company now, but like essentially Boring Company is competing now against a bunch of these tunneling companies who really didn't come to the table when the time was ripe. And as far as I'm concerned, NASA is one of the best brands in the world, right? So like when SpaceX lands the Starship on Mars and 100 people get out and run into the habitat, right? Then they should be like drinking from NASA branded mugs and living in NASA branded headquarters and driving NASA branded rovers, right? But NASA as an organization is not currently construed or set up in a way that would enable them to meaningfully contribute on that basis. So it may be the case that like you have some NASA branded GNC software on board some of the rovers or something like that. But in terms of like building these big systems end to end and like delivering them at a scale that's actually useful, well, I mean, the record speaks for itself. There are pre-revenue startups here in LA that are significantly further along, significantly closer to a usable product than all of NASA is with its $20 billion a year. And the reason for that is that NASA essentially, again, has to do what Congress says, and it has a mandate to do as it's told. And that does not include doing free work for SpaceX, for better or for mostly for worse.
I have a practical question that I actually get very regularly. What is the ROI of traveling to Mars? Have you spent any time on this question?
Yeah.
Is Mars a business?
I think a lot of people would like to convince themselves that it makes rational business sense to build a self-sustaining city on Mars. And I actually think that if you're trying to internalize the economic output of that city, that's definitely not the case. I think it will definitely have positive externalities in all kinds of ways, but I think meaningfully capturing those would be extremely difficult. So that's my opinion, I guess. I don't think it's worthwhile on a monetary basis. But I think it is a extremely worthy way of disposing of excess industrial capacity, much more so than building large vanity yachts or giant skyscrapers or something like that to kind of flaunt your wealth. The reality is humanity has generated enormous excesses of certain kinds of wealth for quite a long time, and actually doing major investment in building this stuff up wouldn't even make the tiniest scratch in our GDP, and it would be enormously positive for humanity as a whole.
So if you look across the startup landscape, especially within Los Angeles, there's a lot of companies that still fit into, a lot of great businesses that still fit into the old architecture of building small satellites and smaller is better, smaller equals better, and building architecture around that. When you think about everything we've talked about so far about Starship and what it might and what it could do for the industry and for design constraints and mass constraints, if there's an entrepreneur listening to this who's thinking about starting a space business, I know it's a very general question. What advice do you have in terms of like where you think the industry is going and how they should be thinking about design and mission design and problem sets that they should be solving?
That is a good question. I'm actually aware of a number of businesses that have kind of set up already to exploit Starship, knowing that, of course, it's going to take them 5, 10, 15 years to mature their product to the point where they could use it. And they damn well assume that Starship would be available by that point or something like it. So there's a company called K2 that's making very large satellites, and there's Venturi Astrolabs making rovers, and Vast, amongst others, is making quite large space station segments. And I think these are all worthy efforts. I also think that, like, amongst the existing crop of companies that are currently making, say, spacecraft buses that are adapted for the SpaceX transporter missions or something like that, because they're small and relatively nimble, it would be relatively easy for them to pivot towards Starship when the time comes, if that results in an expansion of their business. I think kind of the major challenge for space entrepreneurship right now is that the number of business models that have been demonstrated to actually work in that space is pretty small. So we've got communication satellites, we've got launch, which is quite a small market. Communications, particularly internet, is an enormous market, but good luck competing against Starlink at this point. And then we've got Earth observation, and there's quite a number of businesses in that space, but none of them have really been breakout successes yet. I think they're still trying to understand what the business model should be. So there's obviously room for innovation on that front, and of course the technology is much easier than it was 10 years ago. If you want to build an Earth observation satellite of some kind, but you still have to figure out who's going to pay you and how much, and why is it just always the DoD? Just a challenge. But in our case here at Terraform, you could think of what we're doing here as dual use, right? So like, I've got a blog post somewhere called New Opportunities for Space Companies that lists 9 key areas of technology that SpaceX is not currently full out developing, but will be needed for the Mars city, including compactified manufacturing and spacesuits and a bunch of other stuff. And really the biggest opportunity by far on that list is the synthetic hydrocarbon supply chain, because on Mars you will need a lot of water, obviously, but water is relatively straightforward to make. You'll also need just lots and lots of hydrocarbons of various kinds for manufacturing. And also for fueling up the rocket to fly home. And so I thought, well, I'll start here on Earth, where there's also a huge demand for hydrocarbons, and then see how we go.
Casey, so we've been talking a little bit about what the future of Starship will look like, especially once it's operational. But technically, it's not operational yet. I am very curious what you think about the first 2 integrated flight tests. How do you think they went, in your opinion, and how do you think Flight 3 will go, which could be as early as this month?
Yeah, I can't wait. Flight 3 should be spectacular. Excitement guaranteed. I'm really glad that SpaceX, essentially knowing for sure that IFT IFT1 was not going to make it, right, to orbit, press the button anyway, right? Because they knew that the point of launching was to try and comprehend the unknown unknowns. And they learned a bunch of very useful things, and they're able to fix them sooner rather than later. And so when IFT2 went off, if that had been their first launch, they might have lost the launch because of the launch pad problems or other problems that they since had time to fix. So I think that's just like launch early and launch often. And for something that's as revolutionary as what Starship is, I think the fact that they were able to get as far as they have so quickly in so few launches speaks for itself. Of course, it would have been nice if it was flawless on the first time, but arguably if they had a successful orbital launch and recovery on the first launch, it just goes to show they've waited too long. I think some single digit integer number of failures ramping up is the right number.
When do you think we'll see the first payload deploying Starship launch?
Oh, we'll see the first one they get to orbit. So I think IFT3 is meant to have Starlink satellites on board. So yeah, I mean, hopefully that works out. More Starlink satellites is more better. So that should be super cool. As for starships with the giant chomper thing, releasing some enormous 100-ton monolithic satellite, probably have to wait a couple more years. I think there's a huge backlog on the Starlink front, and there's also a bunch of government work that's a bit backlogged on Starship as well. So, but yeah, excitement guaranteed, and I really hope that they straighten out the regulatory issues so they can launch these off as quickly as they want.
So I want to ask a bit of a leading question related to Starlink, and you've done quite a bit of work on Starlink already. Do you think the Starlink business model works without Starship? Yeah,
they're already making money. I mean, I think that's actually kind of a problem for Starship, because Starship was originally pitched as the thing that would help Starlink make money. But Starship took long enough, and Starlink was kind of behind schedule for a very long time, and then suddenly it was ahead of schedule. So, or I say it should caught up, and then over it was like the dog that caught the car as far as launch goes. But they're already making money, and they're not making money by tying people down and stealing money from them, right? Like they're making money because people who often already have an internet connection are also getting Starlink, so they can have a backup. Maybe you should consider it. So it's $120 a month or something, and it's bringing value to people's lives, all over the world. And the more they can launch, the more they can do that. In terms of low cost interventions that markedly improve people's lives, you've got refrigeration and vaccines and the germ theory of disease and prenatal vitamins and stuff. And then you've got internet access. And if you can achieve all of those, your life prospects, particularly in the less privileged parts of the world, are probably 2 or 3 times better than they would be without any of them.
Well, you brought up a couple things. One, which is that Starship is a business still works today. Do you think the current Falcon family is enough to maintain the replacement cycle of the satellites that are needed on the constellation?
Oh yeah, easily. I mean, they got them all up there, so they can get them up there again. The case in which that would be a problem is if, like, one of their competitors, I mean, like, let's run the hypothetically. Let's say Blue Origin got its launcher and reusability underway 6 years ago, and Kuiper was ready to go. Then, Starlink would be in a more difficult position as far as competition goes. That has not been the case. So in some ways, SpaceX got lucky, or Starship's delays were okay, but it would probably be unwise to count on Blue Origin always being so slow forever. But yeah, credit to the Falcon team. Absolutely incredible what they've achieved.
Do you think that there is or will be political will in the U.S. to support the future that Starship is looking to usher in?
Yeah, I think there's, in general, the U.S. electorate is not necessarily perfectly informed on all matters and all subjects, right? But I think if you asked a person, like, which country landed on the moon, they would know it was the United States, and people are justifiably proud of America's leadership in space.
Casey, I gotta say, last week, and I'm not even kidding, last week, someone very informed who is a doctor, not a PhD like you are, but a MD doctor, who called me and said, "Hey Mo, I have a question. Sorry, a little bit out of left field, but I'm just curious to get your thoughts. Like, what do you think about this whole idea that we didn't land on the moon?" Because she's like, my brother's been talking about it nonstop.
I think conspiracy theories are fashionable when progress is stagnating, if that makes any sense. So it's like if progress is obviously occurring, there's a few people out there who I'd say, like, charitably total nutters, who think that SpaceX is faking the landings of their boosters and stuff. But I don't really care that much about their opinion. It's not relevant to my day to day. But yeah, I think that's certainly something people can like. The amazing thing is, like, Starship gives us a lifeline, right? Like, we can do all the things we want to do in space for less money than it would have cost us to do any one of these things before it or without it. And so, for example, within the astrophysics community, for example, the James Webb Space Telescope was quite controversial because it just sucked up entire budgets for decades after it was meant to. And now it's launched. Everyone's like, hooray, the damn thing works. Well, it damn well better have worked for how much money it cost and how long it took, right? But if we continue on that trajectory, we're not going to launch the next space telescope until today's grad students are dead. So, of natural causes. And that's obviously not sustainable. So I think, you get this every now and then, you get a paradigm shift that allows you to kind of break out of that thing. And the nice thing about Starship is, like, well, it's big enough. You can get the moon and Mars. You don't have to choose between them. It's built for both of them. It will do both of them better than any other single system or architecture. And there's hundreds of them. You can read about them on Wikipedia, could possibly have done, because it's oriented around answering the right question, which is not how do you get a few people there and, like, hang out for a bit and come home. It's how do you build a logistics system, a conveyor belt for transporting hundreds and hundreds of tons of stuff and eventually millions of tons of stuff to wherever you want to go. And then the people are kind of incidental because they're a kind of stuff. Yeah, once you solve that general problem, it's solved in general. So once you've got the Starship, you can build and launch a JWST with a much, much simpler system, much, much more mass, monolithic mirror. If you're prepared to actually try, I think you could probably build and launch 10 JWSTs in a couple of years, and JWST class telescopes. Well, that'd be amazing. I'm sure the scientific community would make good use of it. I actually have a blog in the works right now about, like, what is the largest telescope that you could build with a Starship, largest space telescope. And it's large enough that you could image, like, details of continents and oceans and mountain ranges and deserts and stuff on planets around other stars. So I call it the monster scope in a somewhat tongue-in-cheek way, because, first of all, it's a monster telescope. It's absolutely enormous, right? It's also the monster scope because it's designed to look at monsters, right? If we find alien life on other planets, this telescope would be big enough to tell us what they're like. Maybe not, like, get a high-def close-up, shot of their face, obviously, but big enough that we can maybe detect seasonal migratory patterns or something like that, which would be pretty awesome. Right. And the technology itself can scale as well. So if you say, well, actually, I do want to get the high def beauty shot of the alien dinosaur, you just have to build a bigger telescope. So it's with Starship kind of scale, it's not all that hard. And not compared. It would be absolutely out of the question without it. absolutely impossible without it. With it, it's merely very hard.
Well, I'm glad you brought up JWST, and for the benefit of the audience, Casey, we were alluding to is that, in '97, JWST was estimated to cost $500 million because of an 8-meter mirror design, and then it ended up costing nearly $10 billion by the time we built it, which was many, many, many years.
And a 6.5 meter mirror design.
There you go.
Yeah, I mean, I heard on the grapevine that like the initial costing was as I would say contingent, basically made up a number to get the answer they wanted, but at the same time, like. They recosted it and rebudgeted it, and they still got it wrong, and it was slipping, I don't know, it was like 4-1 or something like that for its entire existence. And part of the issue there, of course, is kind of the nature of the contracting relationship between NASA and its suppliers, who know that they are monopoly providers in a section of the government business that has very little oversight that's actually geared towards delivering value ahead of schedule and time. Like, people forget this, but like, when the Hoover Dam was built, the contractors that did that had never worked together before, and they never built a dam like that before, and they finished it like a year and a half ahead of schedule and under budget. Right, the Hoover Dam, like no one had ever done anything like it ever before, and it stands today. And so, but as I like to say, like if you get a big contract in the aerospace industry and you're independent, Northrop Grumman will buy you, and then the contract will become extremely valuable for them. So that's that's kind of the life cycle there. And again, Starship gives us the ability to break out of that because it gives smaller contractors the ability or opportunity to compete effectively in these, in this business while remaining independent. So overall, better value for the US taxpayer, one would hope.
So as we wrap up, I want to ask a question really about a little bit about the future and a little bit about storytelling. I don't think I even need to ask you. I'm sure you're a fan of science fiction. And in fact, I've been reading more science fiction lately because I've seen science fiction actually is one of my favorite genres of film. And I've seen so many of the movies that I don't have much left. I actually scour, Amazon Prime and Netflix and all of those and all of those streaming platforms to find a sci-fi movie that is good that I haven't seen. So I've actually now started to read. So I've been reading a lot more science. It's just, reading just takes a little bit more time. But I actually, my last question for you, Casey, is how do you think advancements in space technology like Starship now, how do you think they're going to influence science fiction storytelling and our perceptions of what the future of space exploration is going to look like?
Yeah, it's an interesting one. I think you might be referring to a fanfic I wrote for The Martian. And The Martian was published only 10 years ago, right?
That's exactly what I'm referencing.
Yeah. So for those who don't know, The Martian is a fascinating story written by Andy Weir, who's a very clever and lovely man, about a lone astronaut who gets stranded on Mars and has to figure out how to save himself. And a fabulous story. You should read it and watch the film. The film is gorgeous. And it's about the hardest sci-fi you'll ever find. But the drama in the story, if you've ever involved in writing stories, there has to be drama, there has to be conflict, there has to be constraint of some kind. And the constraint in the story comes from the fact that the Mars mission that Mark Watney is stranded on kind of sucks. And it's one of these ones where it's kind of a flags and footprints. How can we spend $50 billion to save $5 billion in just building a bigger rocket kind of architectures? And under Starship, of course, that wouldn't exist, right? And so that gives me the opportunity when I'm writing this blog post to be like, well, Mark Watney gets stranded on Mars in my version, but he's stranded along with 10,000 tons of supplies, and he has so many supplies he doesn't know where they are. Like his problem is he can't find enough food because it's hidden behind all the industrial robots or something like that. So I think it's interesting, but you still need a constraint to tell the story. Probably my favorite Mars book ever written would be the Mars Trilogy by Kim Stanley Robinson, to the point that I'm in this process of extremely laboriously writing a technical commentary for it. It's extremely time consuming relative to, I think, the amount of people who read it. And it's a beautiful, beautiful, beautiful book. But again, like the technical aspect of like, they kind of go from this pre-scarcity to post-scarcity situation over the course of the first book. And it kind of sweeps a lot of the complexity under the rug, but it is fun to think about. So it's kind of interesting, but yeah, kind of in one fell stroke, it kind of demolishes the maybe like 1960s plus era of sci-fi that imagines like, well, Apollo 2.0 or Space Shuttle 2.0 type stuff. But actually, if you go back to the old stuff, like the science fiction written by the JPLers back in like the 1950s, there's actually it's not it's a little dated in terms of its social conceptions, but there's a book called, or a short story, I should say, by Willie Ley, called At the Perihelion, I think, which is set on Mars in a world where essentially rockets are about as capable as modern aircraft. So you at one point they hijack a rocket and then fly across the solar system because they've got some kind of nuclear propulsion. It doesn't go into details that allows them to do that. And so you can have these fabulous space operas where there's technical details and some spacesuits and stuff like that. But at the same time, you're not totally getting bogged down in like, oh no, we're on Mars and it cost us $1 million a day and we're so poor. We don't have any stuff. So yeah, I hope to see some more work there. Actually, I just tweeted yesterday, and I would love someone to try this. I'm unfortunately not talented enough, but there's kind of this undercurrent that runs through Lord of the Rings where the Shire represents the idyllic England of Tolkien's youth. Of course, England was never particularly idyllic, but in Tolkien's youth, of course, everyone's youth, things were always better. It's essentially pre-industrial, and the hobbits in particular are kind of the ideal of kind of quiet, homebody folk who enjoy agriculture and a good time and a bit of a drink and their social fabric. Whereas, Sauron and Saruman are like doing industrialization in the British thing, digging up a lot of coal and burning things and making a mess. I was like, well, we now know that if we lived on a planet that didn't have any coal and didn't have any oil, it would still be possible to industrialize using solar power, right? It would be complicated and it would go in different directions. Right now, we're able to make silicon using the Siemens process, which is extremely energy intensive using hydrocarbons, of course, but it doesn't mean it's not possible to do it some other way, and they would have figured it out. So like, can you figure out a future where the hobbits do this kind of quiet agrarian industrialization using solar power, and eventually master solar power and nuclear power, and then build themselves rockets and launch into space and build a Banksian orbital and then fly across the galaxy. And then the elves tune in again after 10,000 years and are like, huh, what? Something like that. I just think it'd be a kind of a nice image, because I think we kind of lack this vision of the future where humans are both continuing their technological primacy and mastery and like climbing this endless ladder of technical mastery. We're really still incredibly primitive by the standards of what we could be. But at the same time, we are protecting nature and restoring the environment and kind of having this codependent or conspecific kind of situation where the plants are living, and because we've essentially using solar panels to synthesize much of our food, we can rewild all of the United States that's currently under corn and soy, right? And we don't have to use heinous agricultural chemicals, across half the country in the same way that we do right now, because we've basically unlocked a supply chain for our chemical energy that's 100 or 1,000 times more productive per unit area than agriculture. And so there's enough room for humans to live and have fabulous, interesting lives flying supersonic planes around the place. And there's also space for all the animals in the wild places and kind of like cultivated gardens in a way. Like, it wouldn't be totally hands off. You would still have humans in the landscape, but they would be engaged in Tolkien, like Lord of the Rings style, careful cultivation of their environment in a very aesthetic and pleasing way. And I think this is a good vision for humanity, and we need more of this.
Sounds like you have to write a book.
I'm working on one, actually. I don't think I've talked about this publicly yet, but it finally dawned on me that I had something to say about physics. So I'm going to write a physics textbook. It's going to be extremely terse. So most physics textbooks are very, very long. I don't have the time for that. It's going to be about 35 pages or 40 pages or so. And it's just going to contain like Cliff Notes versions of all the fundamentals of physics, essentially what I learned in high school and early college, based on my notes from that period. But the important thing is it is going to be the most beautiful book about physics ever written. I want the book to have the same aesthetic experience when you read it that someone who understands the content will experience about the nature of the universe. Right? I want it to reflect the beauty of the underlying physical laws, and that is really tough because I'm not that talented an artist, but I know what I'm looking for. So that's a start.
When is that gonna? When do you expect that to come out?
I would say like 95% confidence interval between April this year and 2030.
Oh wow, that's soon. Oh, okay, there you go. There you go. Well, you've given yourself a lot of leeway there.
So we'll see.
Well, Casey, I told you when we were doing a little bit of prep for this conversation that at some point I want to do a Lex Friedman style 4-hour podcast. And my first guest, I really hope you'll agree to is you, because there's so many different things you've mentioned, so many little nuggets that I just wanted to grab. But in an hour episode, it's hard to talk about all of it, but you've been an amazing guest. Thank you for doing this. You've been super insightful and very excited to see how Starship evolves and develops and how your predictions fare. But thank you for being on the show, and very excited to have you back in the future, and looking forward to seeing how Terraform builds and develops and what that future looks like. So thank you for being on the show.
It's been my pleasure. Thank you.